into it. There are 9 chapters in this book where the class goes for 10 weeks. The last week of class, we're going to do a review. And then the following week, we're going to offer testing on, it'll be on August the 22nd. It'll be a Monday evening. Usually we offer it on Saturdays. I've talked to our volunteer examiner coordinator, and he's agreed to come in on a Monday evening to do it, so that, I don't know about you, but if I get into a habit of coming every Monday, it just makes it easier. So that's the plan for anybody that wants to do that. And as we go through this, we're going to hit some of the questions that are on the test, but I would suggest that you look up hamstudy.org. This is a website that has all of the questions on it. You can sign up for a free account with them, and it'll have all the questions in the testing pool. There's 403 questions in the testing pool. They pick 35 for the test. So it can be any of those questions. There's certain sections. They pick so many out of this section, so many out of this section. But hamstudy.org will go through all of those questions, and it allows you to answer the question. It allows you to flip over the question and get the history and the information behind it. And then it also gives you a bar graph like I'm 50% competent here. It'll tell you how you're doing in that section. When you get everything up to 100% or even 80%, you're pretty much ready for the test. Now you're going to say, okay, I'm memorizing the stuff for the test. I don't know everything. Watch this. Randy, yes. Do you know the answer to every question on the technician's class? And do you know the history behind it?
I'm going to sit back down now, Joe.
That's what I thought. That's the right answer. All right.
So the questions in there, do they also tell you where to get the answer, or?
Yes. If you flip over the question, it'll give you the reason for the correct answer, and it'll also give you a link to go to get more information on it. So you can read hundreds and hundreds of pages if you want to on it. So it gives you some very good background and very good information. Good question. All right. So I would suggest that. I used hamstudy.org. I started out first just trying to study with a book. I'm going, that didn't work too well for me. I tried another couple of study methods. That didn't work too good. I found this one, and it works really well for me. Now, everybody learns differently. So you might have to play around and see what works best for you. But, yeah, if you run through some of these things, you'll be ready for that test. And
So I'm sorry, you might have answered this question already, but when you take the test, you have to get them all right?
No. You need to get 76%.
Oh.
It's either 74 or 76%. You can, for the technician class, you can miss 9 out of the 35.
So as the tests get harder, the 3 different levels, do the questions get harder, or you said for each?
Yeah, for each one, you get 35 questions on the tech, you get 35 questions on the general, and 50 on the extra. The information that you're covering continually builds upon the other. And so, in a way, you can see it as getting a little more difficult, but it's really different information and just a little more in depth.
A little more technical?
Yeah. The extra class is probably the extra license is probably the most technical of the 3. So, but that's a very good question. All right. So tonight we're going to talk about signals, radio waves, and just the fundamentals. So when you think of a signal, What do you think of?
Frequency?
Okay, think of frequency, sure.
Energy.
Energy, you bet. Chantel, what do you think of?
My phone.
You think of your phone. Okay, there's the generation right there. Okay. All right, well, signals are basically something that gets transmitted from here to Denise and back. That's a signal. I'm sending a signal to you right now. I'm speaking and you're hearing, right? That's a signal. Back in the old days, they would wave flags, right? They would.
It's a sign.
It's a sign. Okay. But the signals that we're going to talk about are the signals that travel back and forth between radios. And all radio equipment is designed to generate and to manipulate radio signals. Now, a radio signal can be electrical energy that might be stored within a radio, or it can be a radio wave traveling through space. And those are the things that it is, and that's kind of what we're going to talk about a little bit more. We've got another member of our class. Welcome.
Thank you.
And your name is?
Lauren.
Lauren. Welcome, Lauren.
Thank you.
Glad to have you here.
Thank you.
Okay. So a radio wave starts at an antenna. And it goes from there. Okay? That's where a radio wave goes. And then you get a radio that receives that signal and it transfers that back into some kind of a tone that you might be able to hear, or a tone that you're going to hear Morse code. That still goes on. But as the radio waves leave this antenna, that is called radiating. You'll also hear it known as radiation. Now, I'm not talking about the radiation that you would get from plutonium-235 or whatever it is, right? Not that kind of radiation. You're not going to get hurt by this radiation. You don't have to worry about getting, cancer from this type of radiation. It's not the X-rays or those types of things. It's not ionizing radiation. And we're going to learn more about that radiation when we get to the safety chapter, which I think is chapter 9. But it's not the kind of radiation to worry about. So we start with a radio. It sends a signal to the antenna, which radiates it out. So right now, coming through this room, as we sit here, there are all kinds of radio signals going through this room. Don't see them, but they're there. How do we know? Radio's in the back room. We'll pick them up. So we know that those signals are there. So that's the basics of how it flows from one to another. So as we think of units, we use the International Unit System when we talk about ham radio. And this can get people confused. It can get me confused. So if you have a prefix of tera, it's basically 10 to the 12th. You got how many zeros behind that? 1. You got 12 of them. That's a pretty big number, right? And you got giga, which is 10 to the 9th. You got mega, which is 10 to the 6th. You got kilo, which is 10 to the 3rd. You got hecto, which is 10 to the 2nd. You got deca, which is 10 to the first. And then it starts going the other way. You got deci, centa, milli, micro, nano, and pico. There are some questions on the test in regards to this. And the questions relating to this will be, if I have 1 kilohertz, how many megahertz is that? That's the type of mathematical questions that will happen on the test. So this is a good thing just to kind of keep in your mind and run through some problems as to how they relate to each other. Like you may hear, how many milliamperes is 1.5 amperes? Any idea? So you got 1.5 amperes. And you want to change that into, what did I say, kiloampere? Milliamperes? Milli. Okay. So you're going the right direction, right? $1,500, yes. You know, my profession is I'm a bean counter, right? I'm an accountant. You think I'd be good with numbers? I'm great with numbers as long as I have a 10 key. Doing numbers up here, not so much. My wife can do them up here, not me. But this is an area where it'll take a little bit of study, and we can get you some copies of this table here. I can print those out and we can get you copies of that. Okay. So that was actually one of the questions that's on the test. 1.5 amperes equals...
Where did you find that up there? I mean, I see 1.5A and 1500 MA.
Yep.
But I don't see the actual, you didn't point out what the actual one is.
Okay. So the 1500 milliamperes. So you got 10 here to the -3. So you take this and you move your decimal place over 3. So here you're going, here's your decimal place, right?
Yes.
You add 2 zeros, you move it over 3, and it becomes 1500 milliamps.
A milliamp is 1,000th of an amp. It's like dividing an amp into 1,000 pieces. So,
Okay.
It can get tricky.
Thank you for explaining.
Yes, thank you for stopping me. Thank you. I appreciate that. And if I do that, if I go too fast on something, pull the reins on me.
You didn't point it out, that's all, and I needed that adjustment.
Gotcha. Nope. Good point, and thank you. All right. So how is that used? That is a good question. We're going to get into that in just a few minutes. Okay. So in regards to this chart, there are 1, 2, 3, 4, 5, 6, 7, 8. There are 10 different questions that they could potentially ask you on the test, and it's all to do with moving that decimal point. And if you look at this, you're going from 1 to 2, then it goes 3, add 3, add 3, add 3. So you're adding 3 zeros as you go up. You're taking away 3 zeros as you come down. And that's how I usually think of it, is I move that decimal point by 3.
By 3?
Yep. Yep, when you're going from, the ones you're going to really use are you're going to use kilo, and you're going to use mega. Those are the ones that we use a lot in radio, and that's a movement of 3. Okay. All right, now we're going to get into some real fun stuff. And this is where my drawing capabilities does not work very well. As my mother used to say, there's one class I flunked in school, and that was art in kindergarten. It hasn't improved since. So if we look at a radio signals going out into space, they basically look like a sine wave. It goes up, comes back down, goes up, comes back down, goes up, comes back down. And these are all the same height, thank you very much. Even though they're not, but they are. Just pretend. In my art, you have to pretend. Okay, so we've got this radio wave that is, it's like water, it's just continually going. Wave in the ocean. And but it varies. They can vary in strength. And when they vary in strength, that's what they call amplitude. So you may have something that's very strong, comes way up here, and it's a very strong radio wave. You could have other radio waves that are not quite so strong. And that's called amplitude, if the strength of that radio wave. Now the continual change as it's moving along, that's called oscillation. So as the signal oscillates, each up and down sequence is called a cycle. So here we're going up, right? And here we're coming down. And let's say we're starting right here, and we get to right here. We're coming back up. That is called a cycle between those 2 points. So that's one radio cycle. One radio wave cycle, excuse me. Now, depending on how many cycles you have per second, so let's say we got this cycle, and it takes a half a second to go from here to here. And we got this one here, takes another half a second. So in 1 second, we have two. We have 2 cycles, right, in that 1 second. Now the number of cycles that happen per second is what is called frequency. Now you're not going to have radio waves that are this slow, okay, that you're only getting 2 per second. That's not going to happen. This is just a very simplified example. But when we measure these cycles, we measure them in what is known as hertz. The unit of measure for a radio signal cycle is hertz. The way I remember that is the car rental place, right? Hertz.
And the frequency was the time?
The number of cycles per second is the frequency.
Number of cycles per second.
Yep. And the unit of measure for frequency is hertz. And it's abbreviated Hz.
Would you repeat that again? So I got number of cycles per second is frequency.
Yep.
And hertz
Is the unit of measure.
Why do you draw a line through your Z?
So it doesn't get confused as a 2. That's why I always do it. That's what I learned when I was in school.
That's a 2?
That's a Z. Because otherwise, you know, if I, is that a 2 or a Z?
That there is a 2.
It is, but some people don't draw them clear. And if this was a Z, you just put a line through it. Then it shows that it's a Z, not a 2.
That is a Z.
That's a Z. Yep. Betcha. All right. So if we have, in this case, we have a half a second and a half a second. So we got 2 cycles per second, right? And that is equivalent to a 2 hertz frequency. So the number of cycles per second is measured in hertz.
Would it be 2 hertz or would it be just 1?
It'd be 2 hertz because it's the number of cycles. We got 1 cycle here, it takes a half a second. We got the second cycle, takes a half a second. So we got 2 cycles. So we got 2 cycles per second. It's 2 hertz. If we had just 1 cycle, if this was 1 second here, it would be 1 hertz. Okay? All right.
So I just wanted to clarify.
Yeah.
So hertz is like the synonym for frequency.
Yeah.
And an amplitude has to do with how wide.
It's how strong.
Yeah.
How strong.
Well, but the word amplitude sounds like it means how wide this, you know.
Yes.
How far up and down.
Yes.
So-
Yes.
And the frequency is how many of them.
Yes. Yep. Exactly. Exactly. So here we got a 2. I run out of board. Let me know if you need that again. I'll put it back up there. So we got a 2 hertz here because we got 2 cycles per 1 second. Now if we have another start here. And we're going to stop here. So here's another radio wave, okay? We're starting here. Just pretend it's right below here. So we're starting here, and we're going to end at the same place here. So we got 1 second. And how many do we have? We would have 1 here, we'd have 1 here, and 1 here, right? So we'd have, so that would be a 3 hertz frequency. Yep. Melissa, you got that?
Yeah, I got it.
Shawnee, you got that?
I got it.
All right. You're explaining it to Melissa, I see that.
Is that a 1/2 second again?
It's 1 second.
1 second.
Oh, you're right. I got to come back up here, don't I? This is where 1 second ends. So we got 3 hertz for a half a second. And then 1, 2, 3. We got 4. We're going to be at about 7 hertz. You're right. Good catch. Good catch. That's a good. That's a good catch. It's easy to catch me off guard and with the incorrect answers. That's why you guys got to correct me. All right. So every signal, every radio signal has the same basic shape. You know, it's basically the sine wave, up and down. Keeps repeating itself. Well, there are times when a radio signal can be what we call out of phase, which, if this is the true radio signal right here, this line, if we had a radio signal you get the idea. This difference right here between this signal and this signal is what we call phase. It's a little bit out of phase. So it's not as clear. It's not as clear as the true signal. So it's just a little bit out of phase.
You lost me there,
So what is the dotted line?
That is a separate radio signal that is slightly off from what the first one is, and so it's out of phase with that first signal.
is it coming from the same place?
Can be, yes. And so we'll get more into this. We're just kind of introducing this concept here. We'll get more into it as we go with the how radios function. But just want to introduce the concept of phase. And it can get very confusing, so I don't want to go too deep into it, or I'm going to get confused.
How many phases can there be?
There can be a few, but normally you get something that's out of phase by a quarter, or you can even get a phase change that's 180 degrees. If it's coming all the way down and then back up and down and back up, that's known as 180 degrees. It's basically opposite.
Part of the same transmission then?
Usually not.
So that's confusing me, and maybe I'm stepping too far ahead here, but does the radio signals follow the same?
Yeah, if two sine waves have a phase difference of 180 degrees, like these that are opposite, you know, one of the waves is increasing while the other is decreasing. That's called out of phase. You're basically going to have a hard time hearing anything because the radio signals are just out of sync.
Are you able to adjust your radio?
You can adjust your radio to get them into
Blend perfectly
yeah.
equal?
Yep. And this really, with the newer radios, it's not that big of a deal because the newer radios will tune themselves. But when you have the older radios that use, you're going to hear radio frequencies such as 147.015. We have that right up here. And in about 10 minutes, Lee's going to be getting on the frequency of 147.015 and conducting a net. And we'll talk about nets as we keep going. But he's going to do that in the back room here. And but how does that equate to? So this is the frequency, which means that our radio wave is traveling what? 147 cycles per second. Yeah. 147.015 to be exact. So how can we convert that into meters? So this is our frequency, right? So we actually take 300 divided by 147.015. And that gives us where we're at in meters. This is going to be in the 2 meter band.
It's going to be in the what?
2 meter band. So within the frequencies of the amateur radio and all radio signals out there is separated into different bands. And it's usually separated by the meters. So you'll have a 2 meter band, you'll have a 6 meter band, 10, 15, 20, there's a 17 in there too, 40, 80, 160. Those are the main amateur radio bands that we use. And within those, there are frequencies like this that are within those. And Can I remember them all? No, nope, nope, nope. So I have a cheat sheet that tells me, you know, the 2 meter band, which is in a very high frequency band, goes from 144.0 to 148. That's what the 2 meter band is. And that's those frequencies in between that cover that. And so if you remember anything for the test, what you're going to want to remember is 300 divided by your frequency equals the meters. Okay? That equation, you want to remember that for the test. And that's the way I always remember if I need to convert a frequency down, if I don't have my cheat sheet, which I usually try to make sure I have my cheat sheet so I'm not out of band. I don't want to be somewhere where I shouldn't be. I usually look at this.
When you're referencing 2 meter band, is that the wavelength of the frequency? Or?
Yeah, pretty much. Yeah. Yep, that's a good way to look at it. Okay. So just for
So that means the wavelengths are 2 meters apart, approximately. I'm just curious.
Yeah, no, it's a good question. I'd have to look. I'd have to noodle that one for a bit.
All right.
But that's good. Speed of light is yeah, meters per second. 300,000 meters per second is the speed of light. Yeah, 300 million. You're right. I got the extra zeros. The extra zeros need to be there. It's 300 million. Okay. So, if we are connected to a speaker and we have signals, radio signals that are below 20 kilohertz, they will produce sound waves that humans can hear. These are also called audio frequencies. Frequency FRQ, which less than 20 kilohertz is audio frequencies. And signals that are greater than 20 kilohertz are radio frequencies. So if we're hearing these, that's because, you know, people speak below 20 kilohertz. You can hear the sound. Above 20 kilohertz, it's radio frequency. It can be transmitted between radios. Okay. Oh, I put some red stuff in here too, didn't I? What is RF radio frequencies? Speed of light, 300 million meters per second. Now I know this is a little bit small to read, and I apologize for that. And I'm sure that this won't work up there. Okay, so we have very low frequencies. Is anything less than 30 kilohertz? Anything less than 20 kilohertz is audio frequency, right? Low frequency is 30 kilohertz to 300 kilohertz. So that's a radio wave in a low frequency range. Medium frequency, that's where the AM radios fall, is in that medium frequency range. And they come in at 300 kilohertz, between 300 kilohertz and 3 megahertz. And once you get to 3 megahertz, we're starting to get into the shortwave HF bands. That's where your shortwave radios work. That's where a lot of your ham radios will work. And then once you get above that, into the 30 megahertz to 300 megahertz, you get into the VHF. You've heard of VHF TV, right? You've heard of FM radio. Those operate in that VHF range. Then you get into the UHF area, which is 300 megahertz, all the way up to 3 gigahertz. And that's where you get your UHF TV. And that's also where amateur radios operate from basically here all the way up through here. So that's where we're usually operating at. So anything above the low frequency, we can operate the radio. So now if we hear some noise in the background, don't worry about it. That's just Lee. He'll be calling the Central Minnesota Emergency Communications Radio Network. And we'll try not to bother him too much. I won't yell at him. So, but, okay. Any questions on this?
You can't expand that, so this looks more like a reading test.
I know it does. And I apologize for that. I will try to get a printout for...
I have pretty good eyes and I can't read.
Yeah, I know.
Are you going to get a printout for us?
Yeah, I'm going to try to get a printout for you of a couple of these slides. Unfortunately, my computer was not working properly tonight, so I could fill up the whole screen.
Okay.
So
That's
I'm gonna.
what I thought you could.
Yeah,
Expand.
I tried it earlier and it's just not working right. So I'm going to bring my other computer next week and make sure.
Well, can you just write on the board
Yes.
the ham radio frequency? I can't, my eyes are getting
Yep, I can do that. And I'm going to cheat. Maybe. There we go. Okay. So very low frequencies operate from 1 kilohertz up through 30. Low frequency is from 30 up to 300. And then we jump from 300 kilohertz to 3 megahertz when we get up to the beginning of the HF bands, which then go up to 30 megahertz. And then the VHF goes up to 300 megahertz. Then we go to 1 gigahertz, where the super high frequency starts. And then the extra high frequency starts at 30.
So what does each one of those actually stand for? I mean, I recognize some of them, but what does like the VL?
Very low.
That'd be very low frequency, medium frequency. Then we get to high frequency, very high frequency, ultra high frequency, super high frequency, and extra high frequency.
So radios are tuned to be within a certain frequency.
They are. Radios are tuned to be within a certain frequency, and I'm probably bugging the heck out of you, Lee.
You're fine. We'll be late, it's okay.
Okay.
Okay, and you were saying that the cam frequencies are in the low and the super high, or is that, well, or extra high, which were, yeah.
That direction. Above low frequency.
Cam radio is,
All the way up, okay.
From medium?
You say we're,
All the way up.
oh, because in the book it says amateurs can use small frequency bands in the LF and higher frequency regions of the spectrum.
Yeah.
Okay, and I just wonder what they meant by higher frequency regions. Does that mean that the ones,
These are your higher frequency regions. As you come this way, it gets higher.
so you're saying that's everything above?
Those are the amateur bands, and that's where, once you get into your technician license, you can operate in this area and just a little bit of that area. Okay? When you get to your general license, you can operate in most of here, might be over closer to here, but then in your extra, you can operate in all these bands. And you can actually operate it down into here. Make sense? Lee's going to correct me when I'm done here.
you're doing great.
All right.
Okay, so there aren't some parts that are reserved for radio, I mean for TV or?
There are.
So that's why I was saying that
So-
some of those,
So there's what the FCC puts out is what's called a band plan. And this shows which bands the different licenses have privileges in. And so they break it down. I mean, some parts of the band is for data only, and I'm sharing this upside down. That's really good. Some of it's for data only. Some of it's for what we call CW or Morse code only. So they have a band plan, so that limits you to where you can operate. So that's why it's very important, as you have your license, that you get one of these so you know where you are licensed to operate. And it's very critical that you do that.
And where do we get that?
Well, this one comes in a magazine that I get from the ARRL, but you can get it on the internet. You
And
can,
it's called U.S. Amateur Radio Bands?
U.S. Amateur Radio Bands. Yep.
Search Google for band plan.
Band plan, yeah, on Google. And Google will tell you. But I am probably going to stop here for this evening. We just have a few more things to cover, which we will pick up next time. We're going to talk about radio equipment and radio equipment basics. And then we're going to also go into Chapter 3. But I know it's getting hot in here. I don't know about you guys, but I'm definitely getting hot.
I'm in a good spot.
And you got the perfect spot back there. But any questions that I can answer for you guys?
I have,
Yeah,
when did your lessons begin?
last week.
So I missed one.
You missed one, and it was just the introduction, so you really didn't miss much at all. Yeah, basically how wonderful ham radio is and
Things it can do.
the things it can do.
Yeah, yeah.
So,
And how often do you offer a course like this?
you know, this is the first one we have